Hey guys. So, what we got going on today is we're going to be doing some advanced concentration calculations for AP Chemistry. In AP Chemistry, sometimes the concentration calculations are not always that straightforward. So, I'm going to teach you how to solve them by looking at the units. The main types of concentration calculation we're going to be doing is the molarity, which is the moles of solute over liters of solution. Very important one to know. The mole fraction, which is moles over total moles, and then the mass percent, which is mass over total mass. These three are the main ones, with molarity being the most important one. That one is the one that we'll use over and over and over again. Okay, so let's look at some examples. A solution with a density of 0.876 grams per milliliter contains 5 grams of toluene and 225 grams of benzene. And we want to calculate the molarity of the solution, the molarity of toluene in the solution. Okay, so we have to picture what we have here and what we're looking for. We know that we have 5.0 grams of toluene, which is C7H8, and it is mixed with 225 grams of benzene, which is C6H6. Okay, so that gives us, in our whole solution, we have 230 grams of our solution, of our mixture. And we also know that this solution has a density of 0.876 grams per milliliter. Okay, and of course we're looking for the molarity, which is the moles over the liters, specifically the moles of toluene, so the moles of C7H8 over the liters of solution. Okay, so these are the two things that we have to figure out. I'm going to go ahead and start with figuring out our moles of toluene, okay? So we know how many grams of toluene we have. We know that we have 5.0 grams of the C7H8. Now we can convert that to moles using the molar mass. So we need to find the molar mass of our toluene. So toluene has 7 carbons, so 12.01, the molar mass of carbon, times 7 plus 8 hydrogen, so 1.01, the molar mass of hydrogen, times 8. Okay, so the molar mass of toluene is going to be 92.15 grams per each 1 mole. Okay, so then we have our grams, our 5.0 grams, divided by that molar mass, 92.15, and that gives you 0.054. We only had 2 sig figs, so I leave it at 2 sig figs, 0.054 moles of our toluene. Okay, so step 1, check. Now we need to figure out our liters of solution. Okay, we know how many grams our solution is, and then we can use the density to convert from grams to volume, which is in milliliters, and then convert from milliliters to liters. Okay, so I'm going to do that one here in the, I'll go back. I'll do it in purple. Okay, so step 2. I said purple. Okay, so if we have I'm doing it in black, 230 grams, and then we know that our solution for each 0.876 grams, that has a volume of 1 milliliter. Okay, and then we know that there are 1,000 milliliters in 1 liter. Okay, that'll leave us to our liters of solution. So we have 230 divided by, I'm going to just put the bottom in parentheses, 0.876, oopsies, backspace, times 1,000. Okay, so both of those are on the bottom. And you get Impossible calculation. Poor K. Okay, take two. 230 divided by 0.876 equals, okay, so that's how many milliliters it is, divided by 1,000 to convert it to liters, and we get 0.2625, so 263 liters of solution. So then to get our molarity, okay, to go back and get our molarity, we just take our moles and divide it by our liters. So we have 0.54 over 0.263. 0.054 divided by 0.263, and we get 0.205. So 0.205 molar solution. And since we only had two sig figs in one of our answers, we would probably want to round it to 0.21. So that is the molarity of the toluene in our solution. Okay, cool? Okay, cool. Let's try another one. Commercial aqueous nitric acid. Okay, so nitric acid, if you don't have it memorized yet, it's one of our strong acids that we will memorize. It's HNO3. Has a density of 1.42 grams per milliliters and is 16 molar. Calculate the mass percent of the solution. Okay, so mass percent. That means we need our mass of our solute, which in this case is HNO3, divided by our total mass of the solution. And then we'll take that and we'll times it by 100 in order to get it in percent form. So we know what's given to us in the problem is that we have 1.42 grams per milliliter of our solution and that it's 16 molar. I highly recommend anytime you see the capital M, rewrite it as moles per liter. It'll make it easier for you to solve this out based on the units. Now, neither of these things tell us how much we have. It tells us things about the solution, but it doesn't tell us how much solution we have. So anytime you get a situation like that, what you're going to do is you are going to assume you have 1 liter of solution. Okay? So when we assume 1 liter, it makes everything a lot easier. If we assume 1 liter, we know we have 16 moles of our HNO3, okay? And then we know we can use that to figure out our total mass as well. So first, let's go ahead and figure out our mass of HNO3 from this 16 moles of it. So we have 16 moles. How do we convert from grams to moles? Molar mass, okay? So to calculate the molar mass of HNO3, hydrogen is 1.01 plus nitrogen, which is 14.01, plus we have 3 oxygens, each with a mass of 16, so 16 times 3. And we get 63.02. So, let me erase that so it doesn't look like a decimal point. We have 63.02 grams per each 1 mole. Okay, mole and mole cancel out. You multiply them, and you get 1,008.32 grams of HNO3. Okay, so that's our mass of HNO3. Now we need our total mass of solution. Okay, so we're going to use this fact that we're assuming that we have 1 liter and the density of the solution to figure out our total mass. okay? Because our solution isn't just the nitric acid, so we can't use the molarity of it. We'll need to use density because that pertains to the solution. So if we have 1 liter, I can just do this real quick, that is 1,000 milliliters. Okay, so if we have 1,000 milliliters, and each 1 milliliter has a mass of 1.42 grams, we end up with 1,420 grams of solution. Okay, so then we can find our answer. Do that over here in this little box. 1,008.32 over 1420, times it by 100 to get it in percent form. Save our rounding till the end. And you get 71.00. So it is 71% nitric acid. Okay, cool? Okay, cool. Let's do an even harder one. Okay, this is one of the hardest ones that we're going to do. Acetonitrile, which is CH3CN, is a polar organic solvent that dissolves a wide range of solutes, including many salts. The density of a 1.90 mole LiBr solution in acetonitrile is 0.827 grams per cubic centimeter. Solve for the mole fraction of LiBr. Okay, so let's write down what we know. We know our solution is 1.90 moles per liter of LiBr, okay, in acetonitrile. And then we know that our solution has a density of 0.827 grams. 1 cubic centimeter is also equal to a milliliter. They're equivalent measurements. So I'm just going to use milliliters here because that'll make it easier for us later, okay, of the solution. And remember, our solution is going to be the LiBr plus the CH3CN. And we're looking for the mole fraction. Okay, mole fraction means that we're looking for the moles of LiBr over our total moles. Okay, again, in this one, it doesn't tell us anything about whether we're gonna, how much we have. So we're going to still assume 1 liter. If we assume 1 liter, okay, that means that we have 1.90 moles of LiBr, and we already have half of it checked off, okay? But the total moles is what's going to be more difficult here, because the only information we have about the whole solution is this, its density. And we know our solution contains both LiBr and CH3CN, okay? So we can't just use a molar mass there because our solution is a mixture. But what we can do is we can figure out our total grams of solution, okay? So if we assume 1 liter, okay, if we assume 1 liter, then we have 1,000 milliliters of solution, and 1 milliliter has a mass of 0.827 grams, which gives us 827 grams of solution. Okay, but we need to get that to moles, but it's hard to get it to moles because it's a mixture. It's a mixture of excuse me, of lithium bromide and acetonitrile. So let's figure out, of that 827 grams, we do know that 1.9 moles of it is LiBr. So let's figure out how many grams that is. Okay, so if we have 1.90 moles of LiBr, For the sake of time, I'm just going to tell you that LIBR has a mass of 1 mole of it is 86.34 grams. Okay, so when you plug that into your calculator, you get that you have 165 grams of LIBR. Now, how does that help us? Well, we know how much solution we have, and now we know how much of that is BR. So to get the grams of the acetonitrile, okay, that's going to be 827 minus our 165. That's the LIBR. So then we do math, 662 grams of the CH3CN. But again, I'm looking for moles. I know my moles of LIBR. I need to figure out my moles of the CH3CN. So we have to convert from grams to moles. So I take my 662 grams of the CH3CN, the acetonitrile. We know how to find molar masses by now, so I'm just going to tell you that the molar mass of it is 41.06 grams. So when you plug that into your calculator, you get that you have 16.12 moles of the CH3CN. So to get our total moles, it is that plus the 1.90 moles of the LIBR. Okay. You add those together and you get that you have 18.02 moles of solution. Okay. So now, again, we're looking for the mole fraction, the moles over the total moles, and we have 1.9 moles of LIBR and 18.02 moles of solution. So the mole fraction equals 1.90 moles of LIBR over 18.02 moles of solution. And you plug that into your calculator, and you get 0.105 for your mole fraction. Okay, cool? Okay, cool. Let's try one more example. Call that a day. Okay, cool? Okay, cool.